This is the second of two videos about Gauss in type elimination. We're going to look at Gauss-Jordan method. You can look at it in two ways. You can get things into Row-Echelon form and then apply a procedure which I'll outline to get it into reduced Row-Echelon form. So just picking up from the last video, we looked at Gaussian elimination and we looked at the Row-Echelon form, and then we could do a bit of solving and come up with the solutions. We did three unknowns over three equations, which we're going to do again in this video. Gauss-Jordan method, which you can reach the state that Gauss-Jordan puts a system in, which is reduced Row-Echelon form, which I made a very brief reference to at the end of the last video. Reduced Row-Echelon form. You can do that either by going from the Row-Echelon form, which that's what I'll do with this system here. But if you want to go from scratch, you can pause the video and take down those points and follow that. You get to the same spot. So I'm going to actually basically use the Row-Echelon form, Gaussian elimination, and then apply the Gauss-Jordan method in the last few steps. What we'll get, as I said in the previous video, is a reduced form like this, still with an augmented matrix. Okay, and we get our solutions for X, Y, and Z if we're doing three unknowns across three equations. So first step is to come up with the augmented matrix, just like we did in the previous video. You see it there. Now, although you'll notice that we want a 1 here, you could start at row 1 and divide everything by 2, and then you'd have a leading 1. Trouble is that introduces some fractions, and you may not wish to be doing all of the EROs with fractions, so maybe hold off on that. You could divide by 2, but I'm going to hold off on that till a little bit later. First thing I'll do to get the new row 2 is to go row 2 minus a half of row 1, so we get 0, and then we get 2, which is 2 on 2, minus negative a half of that, negative 1. So basically we've got 5 over 2 there. Minusing a negative is you're adding 2 on 2 adding 1 on 2 onto 2 on 2, I should say. And we get negative 5 on 2 there. So dealing with fractions, especially improper fractions with sums and differences, is a very good skill to be fluent in. Okay, this one here will be 21 on 2. Now, if you've practiced this a bit, you might be able to handle doing 2 EROs carefully in the one step. If not, separate it. I'm going to get the new row 3. Now remember, from last time we want a 0, and down vertically we want another 0 there. So to get the new R3, if I basically, you can see that it's negative 2 at the moment. To get the 0, I can add R1, row 1 onto that, and we do get 0. And as a bonus, we get our next 0 as well, because we would have been moving across. Okay, so just good fortune there. And we've got 4 and negative 8. Now at this stage, we've got Row-Echelon form. To go beyond that, remember we want 1s on the leading diagonal, we want 0s everywhere else. So what I would recommend you do next is to get the 1s on the leading diagonal. So if we times row 2 by half, we get these values, and then we go for row 2, use improper fractions in a simplified manner, and we go row 2, so that should have said row 1 by 2. Okay, row 2 times, to get a 1 here, we have to multiply it by its reciprocal, so we multiply it by 2/5. So we have 0 still, which is good. We remember, by multiplying by a constant for all the terms doesn't affect the 0, so it's a safe bet for that. That will now be a 1, and there'll be a -1, and that one will be 21 on 5. We have row 3, we need to times that by a quarter. Doesn't affect the zeros. We have -2 there. Now it's worth paying attention. Look at row 3. That's exactly as we want it. We know now that z equals -2, so we don't want to upset row 3. So we leave row 3 alone. I'm going to write it in. Okay, row 3 is set. But what about, we could get a new row 2. We need to get zeros on all of these terms here that are above the leading axis. Now you can see that from the form that we wrote down before. So the zeros in a triangle there. Okay, it's important to get those next. We've got all the zeros below in that triangle, so we need to get the zeros above without upsetting the zeros and ones that we have currently. So if we get the new row 2 by going row 2 plus row 3, those first two values are not affected, and the third one becomes 0. And we have 21 on 5 plus -2, or 21 on 5 take 2. Okay, and in the second row you get 11 on 5. I'm writing in row 1 just to split the steps up so we can see what's going on. You could have tried to address row 1 here, but unless you're experienced, it's probably best to step it out into more steps and do it easily. You'll notice at this stage that both row 2 and row 3 are exactly as we want them, so we do not want to upset them. We want to get 2 more zeros along row 1 as such. We don't want to upset the 1 in row 1 column 1 either. So what can we do? We can apply an ERO of row 1 to get the new row 1 minus a half of row 2. So that doesn't affect the 1 there. But if we subtract a half, correction, I meant to say half of row 3. So it doesn't affect the first one. It doesn't affect this -1/2 here. Half of row 3, so we have, and before we go on, I've just spotted an error, small but significant error. That should have been positive the whole time there. And I, for some reason, wrote a negative down. It is positive 1/2, and I meant to be a positive 1/2, but I wrote negative, so please correct that, because that 1/2 was the result of going row 1 times 1/2. It was originally 1 up there, and now it's 1/2, so please correct that. So going row 1 minus 1/2 of row 3 is 1/2, take 1/2, which is 0, which is what we wanted. And we have to apply that to the -7 on 2. So minusing -2, adding 2, which is adding 2 on 2 to -7 on 2, which is -5 on 2. Lastly, we want to get a 0 here without upsetting the 1 and the 0 on the side there. So we can look at row 2. So to get the new row 1, we go row 1 plus 1/2 of row 2 will do the job, and it won't upset the things we want to keep static as such. And then we've just got to go -5 on 2 plus 1/2 of row 2. So 1/2 of 11 on 5 is 11 on 10. And -5 on 2 is -25 on 10, and we're adding those together. So -25, that's -14 over 10. -14 over 10 is -7 over 5. Therefore, x equals -2. Sorry, z equals -2. Oh, let me start at the top. X equals -7/5. Y equals 11/5. And z equals -2. So that's an alternate way of solving it. If the task says use Gauss-Jordan, you have to use Gauss-Jordan. If it says just Gaussian elimination, just use Gaussian and take it down to row-echelon form. This one was reduced row-echelon form. If the task doesn't stipulate, it just says use some sort of row reduction method with an augmented matrix, you've got a choice of the two of them. Certainly as you get to bigger systems of equation, bigger systems, with 3x3, it might not matter either way, but with larger systems, perhaps Gauss-Jordan has some advantages.